Hi students, in this video I'll be going through the 2010 O-Level Mathematics paper 2 question 8. Alright, so this is a question regarding arc length, sector area as well as mensuration. Right, so let's read the part A of the question. So the part A says that the cross section of a tunnel shaded in the figure above, okay, so I put the figure at the side, right, is a major segment of a circle. Okay, so the major segment of the circle with center O. So the major segment is PQR. Okay, so this is a segment. Okay, and radius 8 meters. All right, so the center of the circle is at O. Okay, the parameter of the major sector POQR is 44. That means P to O, O to Q, and then plus the arc length QRP. That would be 44. Right, so part 1, they want us to calculate the magnitude in radians of the reflex angle POQ. Right, so the reflex angle POQ is over here. Right, so over here we need to apply the formula for the arc length. Okay, so if you recall, let's say we have any sector, right? So any sector. Okay, so let's say this is the arc AB. Okay, so the arc length AB. Okay, we can actually find it by taking the radius. Okay, so this must be the center of the circle. Okay, multiplied by the angle that is subtending the arc AB. All right, so the angle, okay, this angle has got to be in radians. Right, so if this angle is in radians, then the arc length AB, okay, will be R times theta. Okay, so in this case, what they want us to find the angle POQ, right? So this would be the theta over here. Okay, so if I know the arc length, okay, then I will be able to find the angle, right? Because I already know the radius. So I know the radius. Okay, I want to find what's the angle. So I need to know what is the arc length over here. Okay, so are we able to find the arc length easily? Okay, so the info given to us is that the parameter, right, of the sector. Okay, that means P to O, O to Q, and then Q, R, P, the arc is 44. So this means that I can use 44 minus 8 to find the arc length. Once I know the arc length, then I can apply the formula for arc length equals to R theta to help me to find the angle POQ, the reflex angle POQ, right? Okay, so let's go ahead and do the working. So firstly, we're going to find the length of the arc PRQ, right? So arc PRQ is equals to 44 minus 8 minus 8. Okay, so it's going to give you a length of 28 meters, all right? So let's apply the formula. Arc length equals to R theta. Okay, so R times theta equals to 28. Okay, so the radius is 8, right? Okay, and theta is actually the reflex angle POQ. Okay, so I'm going to write reflex angle POQ. So it will be equals to 28. So this will allow me to calculate the angle that I need. Okay, so reflex angle POQ will be 28 divided by 8. So that will give me 3.5 radians. Okay, so in other words, the answer over here would be 3.5. Okay, so the concept that we are revising over here is that arc length, okay, is equals to the radius, okay, of the circle multiplied by the angle in radians that is subtending that arc. All right. Okay, so let's move on to part 2 of the question. Okay, part 2, they want us to find the angle POQ. Okay, so we have already found the area of the triangle POQ, sorry. Okay, we have already found this angle to be 3.5 radians, right? Okay, so now they want us to find the area of this triangle POQ. Okay, so we already know two sides of the triangle, 8 times 8. So over here, do you recall the formula for the area of triangle? So area of triangle, so this triangle is not a right angle triangle, right? So we can use this formula, half AB sine C. Okay, so do you recall this? Half AB sine C. So area of triangle ABC. Okay, so this is given in the formula sheet. Okay, so half times the length of two sides times the sine of the angle. Okay, the angle must be in between the two sides. Okay, so since we have two sides of the triangle POQ already, 8 and 8, right? This means that if we know this angle, then we will be able to find it. Okay, so we already know the reflex angle POQ is 3.5. So we know that one full round, okay, of angle 360 degrees in terms of radians is actually 2 pi. So we can take 2 pi minus 3.5, and that will give us the angle POQ. Okay, now we are looking for the one that is not reflex. Okay, so let's go ahead and find the angle. So angle POQ is going to be 2 pi minus the reflex angle POQ, right? Okay, so it's going to be 2 pi minus 3.5. Okay, so that will give us 2.7832 radians. Okay, so this will be 2.7832 radians. Okay, so now we are able to apply this formula. Okay, but remember, if you are calculating a trigo function, okay, and the angle is in radians, you need to change it to a calculator to radian mode. Okay, so do keep in mind this thing. So area of triangle POQ is going to be half. Okay, AB, now A and B are both 8. So 8 times 8, sine of the angle in radians 2.7832. Okay, so you will get 11.225. Okay, so it will be 11.2 meters squared. Okay, so this would be to 3 significant figures. Right, so we've recapped 2 ideas. One is the arc length formula, and the second one is the area of a triangle equals to half AB sine T. Okay, so the answer over here is 11.2 meters squared. Okay. All right, let's look at part 3 of the question. Okay, so this is a paper 2 question, so it's a bit long now. Okay. Okay, part 3. Okay, the total area of the cross section of the tunnel. Okay, so we have already found the area of the triangle. Okay, the area of triangle is 11.225, right? Okay, so this one is 11.225 meters squared. Okay, so if you want to find the total area, that means now we need to find the area of the sector. Okay, so again, we need to apply another formula. Okay, so if you recall area of sector, okay, if the angle is in radians, right? Okay, we can actually use this formula, half r squared theta. Okay, where r is the radius of the circle and theta is the angle that's subtending that arc, that sector, okay, in radians. So in this case, we have already found the answer. It was 3.5 radians, okay, that we found in part 1. Okay, so this means that we are able to find the area of sector OPRQ actually quite easily. Okay, so let's do that. So area of sector OPRQ equals to half r squared theta, right? So over here half, okay, 8 square, okay, so theta will be 3.5. Okay, so this will give us an answer of 112 meters square. Okay, so this is 112 meters square. So you just need to add up the 2 areas. Okay, so the total area will be equals to 112 meters square plus 1 point this 1 point or 11.2. Okay, so then there's a 1 missing from here, so 11.225, right? So it's 11.225, so 11.225 meters square. Okay, so that will give us an answer of 123.2 meters square. So we're going to round up to 366, so 123 meters square. Okay, so this will be 123 meters square. Okay, so so for 3 parts we applied 3 different formulas. Okay, so these are 3 very important formulas that you will definitely need to know for the O-level exams. Okay, so let's look at part B of the question. So part B is a mensuration question. So as mentioned, this is a paper 2 question, that's why it's very long. The whole question is 12 marks in total. Okay, so let's read a question. A traffic bollard consists of a pyramid VABCD attached to a cuboid. So you have a pyramid attached to a cuboid. Okay, ABC and EFGH are squares of side 10 cm. Okay, so the base and the top of the cuboid of the block, okay, is a square. Okay. Okay, then you have a pyramid on top of at the top of the cuboid. Okay, the vertical height Vn of the pyramid is 12. Okay, so it's stated in the diagram. VA equal to VB equal to VC equals to VD. Okay, this means there is a right pyramid whereby the center is of the pyramid, okay, is directly below, the center of the base of the pyramid is directly below the vertex. Okay, so it's a right pyramid. Okay, because all the four slant lengths over here, okay, the slant edges, right, VA, VB, VC, and VD are equal. Okay, then AE equals to BF. Okay, AE equals to BF. Okay, so that means the sides of the cuboid, okay, all have the same length. Okay, so that means the cuboid is standing vertically upright. Okay, because all the four side edges, right, are the same length. All right. Okay, next one. Okay, they want us to calculate the volume of the block. So we need to calculate the volume of the cuboid, which we can do so easily. Cuboid is just sorry, half times base times height, right? Okay, and then for the pyramid, okay, we need to recall the formula for the volume of the pyramid. So it's 1/3 base area times the height, right? Okay, so let's go ahead and calculate the volume of the block. So volume of block equals to the volume of the cuboid, okay, plus volume of the pyramid. Okay, right, so the volume of the cuboid is just length times breadth times height. Okay, volume of the pyramid is 1/3 times the base area, okay, times the height of the pyramid. Okay, so let's call it h1 to differentiate from the height of the cuboid. Okay, okay, so you will get 10. Okay, so it's a square base, so it's 10 times 10 times the height 30. Okay, then 1/3. Okay, the base area of the pyramid is also a square. Okay, 1/3. Okay, times 10 times 10. Okay, and the height of the pyramid is this vertical height given over here, which is 12. Okay, so you can easily compute the answer. You'll get 3,400 cm cubed. Okay. Okay, so the answer over here is 3,400. Okay, so the volume of the pyramid is not given in the formula sheet. Okay, so you need to remember that it's 1/3 times the base area times the height. Okay. Okay, basically it will be 1/3 the volume of a cuboid that has the same base area and the same height. Okay. Okay, let's move on to the last part of the question. Okay, they want us to calculate the surface area of the bollark, but we do not need to include the base of the bollark, which is the square base. Okay, which means that now we just need to add up the four sides of the cuboid and then the four triangles of the pyramid. Okay, so since this is a right pyramid, all the four triangles are the same. Okay, since the length AB, BC, CD, and AD are all 10. Okay, so in other words, we just need to find the area of one triangle. Okay, let's say we find an area of triangle VBC, then we can multiply by 4. Okay, so let's go ahead and find the area of one triangle. Okay, so if you have a figure like this, to find the area of one triangle, basically what we need to do is we need to find this slant height of the triangle. So where is the slant height? Okay, so if I extend this line horizontally across on the base of the pyramid, and then after I draw this line over here, okay, then this will be the slant height. Okay, let's call this point this point M. Okay, so VM will be the slant height. Okay, VM will be perpendicular to this length, this side BC of the triangle. So now we are looking at triangle VBC. Okay, so it will be perpendicular to that. Then once we have VM, we can use half times BC times VM to find the area of one triangle. Then we can multiply by 4. Okay, so now our objective is to find VM. Okay, so this triangle VNM is also right angle because as mentioned earlier, it's a right pyramid. the point N is directly below the point B. Okay. Okay, so what is the length of VN? Okay, so over here you see that AB is 10, right? Okay, AB is the same length as EF. Okay, so if you go from the center all the way here, this NM will be exactly half of the length of AB. So this will be 5. Okay, if you extend over to the other side, then that will be the other 5. Okay, so NM is going to be 5. We know the height to be 12. So now we can use the Pythagoras theorem to help us to find VM, right? So let's do that. Okay, so using Pythagoras theorem, okay, VM equals to square root 5 square plus 12 square. Okay, so this will actually give us 13, right? So this one is in cm. Is it cm? Okay, it's in cm. Okay. Okay, so 13 cm. So Vn is 13 cm. Okay, so once we know Vn, then we are able to find the area of one triangle already. So let's do that. Area of triangle VBC is going to be half times the base, right? Okay, so the base will be BC times VM. Okay, so it's going to be half times 10 times 13. So it's going to give us 65 cm squared. Okay, so that's the area of one triangle. Now we just need to multiply by 4. We have the 4 triangular surfaces. Okay, then find the area of ABEF, right? Okay, one surface, then we multiply by 4. So, okay, around the cuboid. Okay, so the surface area of the bollards would be surface area of bollards equals to 4 times area of triangle VBC plus 4 times area of ABFE. Okay, so this will be 4 times 65 cm square plus 4 times. Okay, so area of one face of the cuboid will be 30 times 10. Okay, or 10 times 30. Okay, so that will give us an answer of 1460 cm square. Okay, so this one still not considered too difficult of a question. Okay, so you just need to know the main thing okay, for this part, how to find the area of the one triangular surface of the pyramid. Alright, so this is the 2010 paper 2 question A.